And that's right there, a demonstration of energy for you folks. Hello, hello. My name is Yakir Arbib, and I'm a pianist and composer. And here is my great teacher and friend.
Tomer.
And he's a great physicist, upcoming physicist, who promised me for many years that he's gonna make me a specialized physics course. And we thought we'd share this with you, ladies and gents. So tune up and listen well.
Yeah, this is really exciting. This is the next video, the second video we are recording. We did the first one just now. And this now we're going to talk about energy, which is really cool.
Great.
Because it what helps you when you try to, push someone or hug someone. And
many other things that we won't mention here on this tape. Yes.
yeah, and this is the first time I'm teaching it this way, so I'm very excited. And also, this whole course is, as you can see, it's pure audio. It's just verbal, and it works well for everybody, and it's really fun. So now we're going to talk about energy.
Yeah.
So Yakir, we just spoke about velocities and things falling, and average velocity and what we call instantaneous velocity in a certain moment. In the first moment it was 0, then after 1 second it was 10, but average velocity was 5 during the first second, etc., etc.
Mm-hmm.
So we had time, velocity, and distance. Now with this new idea of energy, we're going to eliminate time. We're going to ignore time, and time will no longer be present in our calculations.
Oh, great.
So it's great. We're going to have just 2 things instead of 3. So the beautiful thing is that time conserves. This is how we say it. That time is conserved.
Mm-hmm.
Energy is conserved in time.
Mm-hmm.
So energy stays the same. And for our discussion right now, we're going to talk about 2 kinds of energy. We're going to talk about kinetic energy involving movement. So when things move, they have energy. Like Yakir, when he's playing the piano and his fingers are moving, there's energy there. And the second thing is that gravitational energy. When things go up, they absorb gravitational energy. So how do you know the energy is there? Because when they go up and then you throw them down, they get velocity again. So
Yes.
they have kinetic energy.
Yes.
So the two things work together. They're 2 kinds of energy, but it's the same energy.
Mm-hmm.
So the way we calculate it is this way. For gravitational energy, you take the mass of the object, let's say 1 kilogram,
Mm-hmm.
and you multiply that by 10, which is the gravitational acceleration.
Mm-hmm.
Why 10? We just said before, if you drop something at the initial velocity of 0 meters per second, after 1 second it's 10, after 2 seconds it's 20, after 3 seconds it's 30, so it's 10 every second.
Yes.
That's the acceleration. So if you have something that's 1 kilogram, so you multiply the mass by 10 and then by the height. So if you have something that's 1 kilo, the mass is 1 kilogram, and it's 1 meter off the ground.
Yeah.
So you multiply 1 kilogram by 1 meter by 10,
Mm-hmm.
then you have 10 joules.
Yeah.
That's the so
Energy are calculated with joules.
yeah, energy with joules. So that's 10
Wow.
joules. I could be wrong here about the units. I have to admit. No, I'm pretty sure it's joules. I haven't looked it up before. This is totally spontaneous. So that's 10 joules. Okay. So and if you have something that's the mass is 2 kilograms and it's 2 meters off the ground, how many joules is that?
Oh, I'm still dazzled by the shining jewels that I'm envisioning here.
Yeah,
A lot
absolutely.
of rubies and gold and silver.
Yeah. You're gonna get one if you answer this question right.
Thank you. In other words, it's your way to say shut up and start thinking. Thank you.
No, don't think, please.
Don't think. Yeah, we already established that the best mode for thinking is not thinking,
Yes.
which is quite catch-22-ish, which is in line with this time.
The
Anyway,
Zen
what
master,
was the question?
The Zen master. If something is 2 kilograms, the mass is 2 kilograms and it's 2 meters off the ground, how many joules are its energy? Its potential?
So it would be 40, I think.
Absolutely, 40. Very
Because
good.
we multiply.
Yeah, we take the banana, we put it in the omelet. Yeah, you know how it goes.
Exactly. Okay.
So, so now the other kind of energy, the kinetic energy. it goes like this. You take the mass, you multiply it by half, okay?
Yeah.
And then you multiply it by the velocity squared, meaning
Okay.
the velocity times itself.
Yeah.
So let's say the velocity is
10.
10. Okay, 10. The velocity is 10, and it's 2 kilos. Okay. So what's the kinetic energy?
10.
Wait, it's the velocity squared.
Oh, sorry. Then it's 100.
Very good. Okay, and if the velocity
Because
is,
you multiply 2 by you put the what was it?
You put the water in the hole and you take the wife out of the room.
Sorry, my teacher is very patient with me.
Yeah, very patient. So thank you. By the way, this is sponsored by Lemons Incorporated. They grow great pomegranates and and tangerines. Just buy their lemons and
Yeah. So place your order today.
place your order today. You know, only online 999-333.
00.com.
Okay, so here's how it goes. The energy is conserved. So if you throw something up, okay,
Yeah.
you throw something up. Let's say that initially it has no gravitational energy, only kinetic energy. Okay, and let's say you throw something up, and the velocity is 10 meters per second. Okay, we already know how much time it would take it to stop.
Yeah.
Okay? How much? A million years. Yeah.
Yeah.
Exactly.
Exactly. Okay.
And the distance we also know. Yeah.
Yeah.
Yeah, until it stops. How it's going to stop? It will be like, whatever.
That's the answer. Until it stops, ladies and
until
gentlemen.
it stops.
It will stop when it will stop.
Until your nose hits the ground.
Yeah.
But we're going to do it now in a different way. We're going to say that the energy is conserved. Okay.
For the answers, by the way, ladies and gents, check out our first lesson. Yeah, please.
Yeah, thank you. We're going to first calculate the energy in the beginning. Okay. So that was, let's say that this thing has a mass of let's say 2 kilograms. Okay.
Yeah.
So 2 kilograms, and the initial velocity is 10 meters per second.
Yeah.
So what's the initial energy?
Which energy? Kinetic or gravitational?
It only has kinetic in this point.
So it's 2 kilograms by...
we just did this calculation. You just gave me the answer earlier.
40.
No.
100.
100, exactly.
Okay.
Because you...
Oh, that's the gravitational energy.
Yeah, exactly. That's... Okay. So the idea is that the energy at the end will be the same as the energy in the beginning, also 100. You look like you just ate something bad.
No, I was just thinking about it.
Yeah, good. Yeah. So
the aftertaste of the pomegranates. Yeah, go ahead.
Exactly. So the energy at the end is 100 joules, okay?
Yes.
And the energy in the end is only gravitational. So it's only this thing which is like the mass times 10 times the height, okay? And we know that should be 100.
Yes.
Okay? So can you calculate the height from this formula? If something is 2 kilograms heavy, and it only has, when it reaches the maximum height, it stops. So it only has gravitational energy. Okay? And this gravitational energy is worth 100. And it also is the mass times 10 times the height.
Okay.
And you know the mass, right? It's 2.
Yes.
So can you give me the height from this equation?
So we have it's 2.
It's 100, yeah.
100 of energy, and the formula to get that said it's mass times height times
10.
10.
Yeah.
Okay. So we would have 5. I think.
5.
Yes.
Wonderful. Yeah, you see, it's magic. How did it work? I don't know. You want to have a pizza?
נראה שאתה מורה מצוין.
Yeah.
תלמיד חרוץ.
Thank you.
Yes.
Great. So it's 5, just as before, yeah?
Yes.
Okay. Now it may seem at this point that we changed an easy calculation into a complicated one, yes?
Yes.
But there are other situations where this way of thinking would be easier, yeah? For example, we know that if something is 5 meters off the ground, 5 meters off the ground. We know how much time it will take it to reach the ground. Yeah.
Yeah, when it will reach the ground.
When it will reach the ground, exactly. And if it's 5 meters, and we also
For
know
answers, check out our first lesson. Yeah.
yeah.
Right.
And if it's 20 meters, and if it's 45 meters, we know the answer to all of these.
Yes, of course, 3.
But if it's 1,000 meters off the ground,
There we have to include some Fibonacci scales.
Yeah,
some,
exactly.
Or
We
some,
need to-
or some logarithmical.
we need to ask the crystal ball,
Exactly.
or we can use energy.
Uh-huh.
So if I drop something, I drop something from 100 meters high. 1,000 meters.
Yeah.
Okay.
Mhm.
Should we go for 1,000 or 100? What do you feel like doing?
Let's go for the crystal ball.
Let's go for the crystal. Exactly.
But what if you drop the crystal ball from 1,000 meters?
It may never hit the ground.
Wow.
It will just float out into space. Okay, let's do 1,000. Let's do 100 meters off the ground. Okay.
Okay, that's. I feel already better. Yeah.
Yeah, let's do so what's the energy? If it's let's say it's the mass is 2 kilograms. So
Yeah.
what's the energy?
I need to know the height.
100 meters off the ground.
Oh, okay. Oh, it's not the height of the object, but it's the height.
Yeah.
So it's 2 times 100. It's 200,
Yeah.
and then times the energy.
Times 10. Remember that's
times
the formula.
10.
Times 10.
That's
So
right.
that's
So it's a
2,000.
2,000. Yes.
Okay. Not 2 million?
No.
No. Okay. Just
Almost.
2,000. Almost. So so it's the energy is 2,000 joules.
Mhm.
And okay, so that's going to be the same energy as in the moment of impact on the ground. And in the moment of impact on the ground, okay,
Yeah.
it only has kinetic energy.
Mm.
Okay, so now we have an easy way to calculate the final velocity, the velocity at the moment when it hits the ground.
Okay.
So so you want to try and do that velocity?
I mean, so we have 2,000 meters. No,
2,000
2,000
joules.
energy,
Yeah.
joules.
Yeah.
And we are
that's-
100 or 200 meters off the ground.
We
100.
were 100, but
100.
now we're at the ground level, and we have a formula to calculate kinetic energy, which is half times the mass.
Ah, yes. Okay, half times the mass.
Yeah.
Which is 2 kilograms. So we have 1. And
So that's 1.
Yeah, and then
And
times the velocity squared.
Squared, exactly. So
So
the velocity will be
x.
the square root of 2,000, whatever that is.
Okay,
If I gave you
it's
instead
an
of
equation, no?
yeah, what's the square root of 2,000? I don't know. If instead of 100, if we started not 100 meters off the ground, but let's say we started 200 meters off the ground, yeah,
Yeah.
or maybe 200 meters off the ground. Okay.
Mhm. Yes.
I'm trying to give
It's getting very high here. Yeah.
yeah, I'm,
This is
I'm trying to
right.
give something that will be rather rather
Impossible,
No, so-
incomprehensible,
yeah.
irretrievable.
What's this? Okay, what's the square root? 128 something. 128
Something?
meters. 128 meters. If it starts from 128 meters off the ground, okay,
Yes.
and it's 2 kilograms.
Yes.
Then the
Kinetic energy.
then the no. Let's start from the gravitational energy.
Oh, okay.
So it's what's the gravitational energy? It's 250. No, it's
Yeah.
128 meters off the ground, and it
Yes.
weighs
2
2 kilograms. So what's the gravitational energy?
It's 256.
Beautiful. Yes. Yes. Times 10, right?
Yeah.
Times 10. So so now we equate that with the
Which
kinetic
is
energy.
2,000 something for the record. Yeah. Exactly.
And now we equate that with the kinetic energy in the end. Yeah.
Yes.
So in the end, so we say that's 2,000. We said 2,560, right?
Yes.
And that's equal to half times the mass, which is 1, right? Because the mass is 2, so half time. So that's just equal to the velocity squared.
Yes.
So instead of the square root of 2,000, now we have the square root of 2,560.
Which
Which
is even
is-
easier.
Yeah, I think that should be like 16 times the square root of 10, something like that.
16 times the square root of
Because-
10.
yeah,
What's the
because-
square root of 10? Like,
The square root of 10. I think is like around 3, right? Because
Around.
it's close to 3.
somewhere there. Yeah.
It's close to
That
3.
vicinity, yeah.
So let's say that's more or less 3, okay?
Mhm.
And so 3 times 16.
Why
yeah?
16?
Because 16 is the square root of 256.
Ah, okay.
So 3 times 16, that's 30 times 18, that's 58, right?
Mm-hmm.
Am I right?
Say it again.
No, that's 48, sorry, 48.
Yeah.
So we know the velocity is 48, approximately, good approximation, 48 meters per second.
Mm-hmm.
So this way, we made this, we did a different calculation, yeah?
Mhm.
Instead of using time, we just have these two, we use mass instead of time
Yeah.
to calculate the final velocity.
Mm-hmm.
And it's great. You can do that the other way around. You can start from the velocity and end in the rotational energy if you throw something up and you want to know how high it's going to go.
Mm-hmm.
And you can do that for horizontally throwing things and whatever you want. And
Just get wild and try out things, ladies.
yeah,
and
exactly.
gents.
And the nice trick here is that suppose you're going on a roller coaster, which is
Yeah.
something you really like to do, right?
Of course.
So you go up and down and in every direction, yeah, and you want to know what's going to be your what's going to be your final situation.
I'm sure that every one of you thought of this,
Yeah.
of their fun. I'm sure that everyone thought of their
Velocity.
average velocity while they're
while-
concentrated on not having a heart attack
yeah,
while
exactly.
facing the big slide. Okay.
Yeah.
I'm
So,
sure.
yeah, I'm sure.
If you do this, please contact us.
Yeah,
And you'll
contact
get
us.
a special prize.
Special prize, like this beautiful,
Yes.
you get this.
The Genius of Physics 2017, let's say, because we want to give you guys time.
And eat a lot of hummus.
Yes. Love you guys.
Bye.